Starting point for question 1 is to multiply everything through by 5 to get rid of the fractional term. So the first term multiplied by 5 just leaves the denominator, 3t minus 4. Next term multiplied by 5, minus 3 times 5 minus 15 into 1 minus t. And the right hand side, again multiplying by 5, 4 times 5 is 20. And then the minus 2 times 5 gives us minus 10 into 3 minus t. Next thing to do then is multiply out the brackets. So it's 3t minus 4 minus 15. Minus 15 times minus t gives us plus 15t. And then on the right hand side we've got 20. Minus 10 times 3 is minus 30. Minus 10 times minus t is plus 10t. Next, get all the t terms on the left hand side. So it's 3t plus 15t. 10t crosses the equal sign to become minus 10t, or just think of subtracting 10t from both sides of the equation. On the right hand side, 10t minus 10t cancels, or gives us 0, and then on the left hand side we must also subtract 10t. So, the other terms, minus 4 must cross the equal sign to become plus 4, minus 15 crosses to become plus 15, and then 20 minus 30 is minus 10. So on the left we've got 3 plus 15 is 18, minus 10 gives us 8t. And on the right hand side we've got 4 plus 15 is 19, minus 10 is 9. Divide both sides by 8, or use cross multiplication to move the 8 down underneath the 9, and we end up with t equals 9 over 8. Question 2, part 1, we need to use the chain rule, because we've got a function of a function, we've got a cube of a function of x. So we can say d with dx is treating the bracket as a single variable 3 times the bracket to the power reduced by 1. Then chain rule says we must multiply by the derivative of the inner function, which is going to be minus 4x. That's the derivative of 1 minus 2x squared. So the content of this bracket doesn't change. Or more formally, if we say that the bracket is equal to v and our function is f, then df by dx is df by dv times dv by dx. So if we're saying f is v cubed, df by dv is going to be 3v squared times dv by dx, which again is minus 4x. Replace v with the contents of the bracket and we see we end up with the same thing. So either way is fine. Part 2, we've got product of functions. So we use the product rule. It says the derivative is equal to the derivative of the first function, so that's 4x cubed, times the second function, e to the x, plus the derivative of the second function. Well, the derivative of e to the x is e to the x, times the first function, x to the 4. You can take out a common factor then of x cubed e to the x, since both of those appear in both terms. Then to decide what goes into the following bracket, divide the original terms by the common factor. Well, x cubed cancels with x cubed in the first term, as does e to the x, leaving us with 4. For the second term, again, e to the x cancels, and then x to the 4 divided by x cubed leaves us with plus x. Part 3, we need to use quotient rule, and the derivative of the quotient is derivative of the top function, so 2x times the bottom function minus the derivative of the bottom function, which will be 2 times the top function, all over the denominator squared. And we can tidy up the numerator here. We've got 2x times 2x is 4x squared, minus 2x squared is 2x squared, and then we've got 2x times 3, so plus 6x, all over 2x plus 3 all squared. We could take 2x out as a common factor in the numerator, and then that will give us x plus 3, all what else you can do there. Number 3, we're asked to integrate both sides. So the left hand side, well, it's the derivative of s with respect to t integrated with respect to t, so if you integrate a derivative you end up with the original variable, so left hand side this becomes s. On the right hand side we can put the 20 down straight away and then just integrate what's in the bracket. So 3 with respect to t is 3t. If you want to think of that in terms of the power law, you can think of that 3 as being 3t to the power 0, because 3 to the power 0 is 1, and we know that the integral of t to the power 0 is going to be t to the power 1, because we increase the power by 1 and you divide by the new power. Or you can just think of the integral of a constant being the constant times t. And then we've got 1 over a term. Well, whenever you see 1 over something, you should consider natural log as being a possibility when it's a single t term or a single variable plus a constant. So that indeed is the case here. So the integral of 1 over t plus 2 is just natural log of t plus 2. And then we need to add on c, constant of integration. Then we can make use of the initial condition that says when s is 30 natural log of 2, so we replace the left hand side s with 30 natural log of 2. That's when t is 0. So on the right hand side we end up with 20 times in brackets 0 plus natural log of 2 plus c, and therefore c is 30 natural log of 2 minus 20 natural log of 2, so 10 natural log of 2, and therefore s can be rewritten as 20 into 3t plus natural log of t plus 2 plus c, which is 10 natural log of 2. And then we could use log laws to rewrite this. First of all, take out a common factor of 10. Then in the brackets, for the first term we've got 20 times 3t, so that's 60t, divided by 10 is 6t. Then 20 natural log of t plus 2, divide that by 10, leaves us with 2 natural log of t plus 2. and then the last term there, divide that by 10, and we get plus, that's for log of 2. And we know that we can use these rules that n log a is the same as log a to the n, and also that log a plus log b is the same as log ab, to recombine the terms there in the last line. So if we do that, we can rewrite this as 10 into 6t plus natural log of, well, the 2 goes up to become a power of t plus 2, so t plus 2 squared, then times 2 using the second rule there. So 2 into t plus 2 squared